14.23 for each of the following gas phase reactions indicate how the rate of disappearance of each reactant is related to the appearance of the product. So, since there's a 1 in front of here, for every one of these concentrations of H2O2 that disappears, that's why there's a minus sign, per unit time, we have appearing one of these H2s for every unit time, plus we also have, well, equal to, plus one of these O2s that's appearing as well, the concentration of O2 per unit time. Then in letter B now we start to get in where we have some coefficients, and remember it's always the inverse of the coefficient, and so for the disappearance of 1/2 of the change in concentration of N2O per unit time, we are equal to the appearance, so positive sign, of the 1/2 of the concentration of N2 per unit time. Whoops, triangle time right here. I should have a triangle in front of this as well because it's change in that, which is equal to 1 of these O2s, so concentration of O2 per unit time. Then letter C, we now have the disappearance of the concentration of N2 per unit time is equal to the disappearance of 1/3 now of the concentration of H2 per unit time, which is equal to the appearance, or positive, of 1/2 of the concentration change of NH3 per unit change in time. And then lastly, for letter D, it would be the disappearance of the change of the concentration of C2H5NH2 per change in time is equal to the appearance of the concentration of C2H4 per change in time, which is equal to the change in NH3 concentration per unit time. And this one would be positive as well because it's on the product side, so it is appearing.